Gita, and everyone here at the Network of Researchers on the Chemical Evolution of Life for this opportunity to get to speak with you here at this important webinar, considering the question of, is humanity settling its own fate on ecological survival? It is a pleasure and an honor to get to speak with you here today about this. What I would like to kind of focus on is this issue of human population growth and the degree to which it offers us a set of largely, but not completely unprecedented questions here. And I put up this graphic, I think a little bit about how in the Hindu tradition, Brahma, Vishnu, and Shiva give expression to the experience and the relationship of creation, destruction, and preservation. We will discuss somewhat related themes here through not Brahma and Shiva and Vishnu, but through oxygen, carbon, and hydrogen, and the different ways that the elements combine. Anyway, and we'll talk about the issue of growth and of extinctions and of sustainability. And of course, the last conference of NoRCEL looked at the chemical evolution getting us to life, in which the elements fused in stars then formed into chemicals, both first in space and then here on Earth, so that we had amino acids and proteins and lipids and RNA, and we formed a relationship between metabolism, membranes, and reproduction in that very first form of life on Earth. So in that sense, chemicals make life possible. It is what life is about. And so you have the evolution of life coming out of the researchers, of people who are engaged in NoRCEL. And then we have now, whether or not things get better or not, at least they become more complex over time. Once we have that first life form, it goes through a bottleneck, and we have the last universal common ancestor. We have Luca. And from there, we have a 3.5 billion or so, excuse me, evolutionary biological evolution, getting from that first relatively simple prokaryote cell to where we are today. We're going to skip over all of those fascinating developments of that 3.5 billion years and get to where we finally evolved, which in one sense is very recent. We've only been around for some 300 to 350,000 years at most, compared to a nearly 4 billion year history of life. That's next to nothing. But for good reason, we are very interesting to ourselves. And in many ways, we represent a very complex form of sets of relationships that has taken a very long time to develop. One of the ways that our experience leads us to an unprecedented set of questions is in regards to this question of population. Our population, at least relative to where we are now, was very low for almost that entire 300,000 year history of our past. I mean, when we go back 300 and some thousand years ago, we're maybe in the thousands of people, most likely in Africa, it seems like where our kind originated. But jumping way ahead to just 10,000 years ago, we were still a total of around 4 million individuals. By this point, we had dispersed throughout most of the Earth. Relative to where we are now, 4 million is a very low number, and that number remains relatively low for a long time. Just 2,000 years ago, we were up to 190 million. That's a population growth. But it really doesn't take off until only a couple of centuries ago. We finally reached 1 billion of us just after 1800. And since then, our numbers have been skyrocketing, at least so for us, for those of us who are humans. We have this unprecedented situation of going from 1 billion to now almost 8 billion presently, with projections of around 11 billion or so by the end of our current century. So this is a phenomenal growth that we've had, something like which we've never had before, and it presents us with new questions. It's also worthwhile to remember how long our numbers were relatively low. For so much of our history, reproducing enough so that our groups could survive was of great importance. So we had to pay a lot of attention to that. And this has influenced so much of our culture. We are now needing to relearn what we need to do to deal with our sustainability in the face of this unprecedented population growth. And we are worried that what seems to be very high levels of population is adding to the pressures on our long-term even survivability. And that what we want to look at here is how the elements, the chemicals, the types of things that the network researches on the chemical evolution of life, making life possible and then more complex, and for us more numerous, can also cause a great deal of hardships, even extinctions. And this is where that Hindu mythology is sort of interesting, because you've got the different combinations of relationships leading both to life, to growth, and then to some really significant problems. All right, let's go back to photosynthesis. Now, those of us who are not chemists and biologists ourselves can hardly look at blue-green algae and not think that they are absolutely brilliant. They figured out a way of making their own food from water, air, and sunlight. That to me is just stunning. And the waste product of that process is oxygen, which is released. And we think of that as a good thing. We talk about how there are lungs of the planet and we depend on oxygen. Of course, that was not the situation for them. For them, it is a waste product, and it's somewhat toxic. They are anaerobic here at this point. They don't need oxygen. Oxygen is a rather toxic element for them. But they release it, and it releases in great numbers. Here we have some holdovers of that with the stromatolites. Layer upon layer of blue-green algae, which still exists in Western Australia. At first, that oxygen interacts with iron and it rusts, and so we have now the results of this, these beautiful bands of color in the rock that came about because of the rust that oxygen made possible. And in addition to this causing rust of iron, it also built up in the atmosphere. Now, this is a very different situation than the atmospheric changes that we're going through, because relative to our experience, these are very gradual but persistent changes, so that we finally start to have the accumulation of oxygen in significant levels in our atmosphere over, from our point of view, great periods of time. Again, from our point of view, we're really pleased that oxygen developed in the atmosphere. For the prokaryote cells, this was for the anaerobic life forms, this turned out to be a disaster. And this oxygen, which makes our lives possible, caused the extinction of most of their lives. First of all, they didn't deal well with the oxygen themselves, and then it changed the relative levels of methane and of carbon dioxide, which led, it seems, to a glaciation period from 2.4 to 2.1 million years ago. You put those together, and this life form that had produced oxygen led to conditions which caused the extinction of perhaps 99% of life on Earth. It's a disaster here that we have because of the Great Oxidation event. And then there's a bit of an irony in that the chemicals that make life possible, then you have life producing elements and chemicals that destroys life. And we have a couple of similar situations after that. So we are facing unprecedented questions to a degree, but there is it rhymes with some previous experiences. The Ordovician Silurian extinction. Here you have life forms, now plants, removing carbon dioxide. As a rule, we think this is a good thing. But it seems at 440 million years ago, that led to, we're worried about carbon dioxide buildups and global warming. By removing carbon dioxide, the great increase in population of plants at this point caused cooling and another period of glacier formation, which seems to have contributed to, again, a great extinction. This time, perhaps 86% of life is lost as a result of that. And we have a similar situation just 365 million years ago, where again, plants cause chemical reactions now of increased amounts of O2 in the oceans, which may have suffocated species, but perhaps that's what led to the next great extinction, in which we have 75% of our life on Earth being lost. So there's a process here of creation of life, of growth of life, and of extinction of life. And there's been a lot of talk about Gaia over the years, that Earth itself it goes through the process which enables the chemical evolution which leads to life, and that Earth has various changes which makes life possible, which is true. But the same Earth which produces life can also form chemical reactions which removes life. And so the Earth itself becomes a bit of a problem. And maybe the Aztecs caught this a little bit with their goddess Coatlicue. Who's to the right of your screen here. She has some very nurturing elements to her. This Earth goddess does produce the plants and the life that we eat and that our life depends on. She also has, as you notice up on the top, some very fearsome teeth. And she's rooted in the land of the dead, where the skulls are. And for the Aztecs, this created a fair deal. We eat from the life that Earth produces, and then when we die and we're buried, if someone digs us up a little bit later, they notice we're just bones, she eats us. It's a fair deal, and there's an exchange which is going on. But in any case, this is a mythological expression of the Earth giving us life, of chemical evolution producing life. But then the Earth, it seems as though through its volcanoes, releases lots of carbon dioxide, and that seems to cause global warming and acidic rain. And we have the Permian-Triassic extinction period 252 million years ago, where 96% of life goes extinct. And then we have a similar process in the Triassic-Jurassic extinction period, where maybe 80% of life goes extinct. And then it's not the Earth which causes problems, but it's the solar system, it's the universe. Sohan was talking about how that marvelous Earthrise picture changed our perspective on Earth, but it also showed how vulnerable we look in this very foreboding dark background. And for 66 million years ago, an asteroid maybe the size of Manhattan or something, comes crashing into the Yucatan, raising debris, cooling the earth. We have 60 to 76% of life going extinct. Among that being the non-avian dinosaurs, which is a bad thing for them. For us, it's a very good thing. It gave mammals the space to evolve into, among other things, us. So you have a mixed bag throughout all of this. That great oxidation event caused enormous extinctions and destruction. It also made aerobic life, our kind, or eukaryote life like us, possible. And you have then another extinction event 66 million years ago, wiping out these grand creatures, the dinosaurs, but making us possible. There's a mixed bag of creation and destruction, and that we cause the same sort of mixed bag. We're an extraordinarily inventive, creative species who have caused for a long time a lot of destruction. And it's not just currently. It seems as though that we contributed, if not caused, the extinction of some marvelous species of animals many thousands of years ago, perhaps by over hunting them. But more currently, we have, for example, in Elizabeth Colbert's wonderful book, she calls it the sixth extinction. I think if you include the Great Oxidation event, we're in the seventh extinction actually, and this comes about in part because of the abundance of human life, this tremendous growth in population that we've had, which is in association with other issues linked to a host of life-threatening issues. And the question that we're asking here today is this important question of, given where we are now, what can we do to find ways to preserve life, to sustain life? We don't want to go through another period where 75% or 96% of life goes extinct. This is unprecedented because presumably blue-green algae couldn't think through that process. We can, or at least we hope that we can. What are some of the direct contributions of population, some of the pressures that we have? Clearly, population growth affects land use. We've had a great increase in cropland and rangeland as we've gone through the agricultural and the pastoral revolution 10, 12,000 years ago, and a much great decrease in woodlands and wildlands as a result of our population. And so
أكتب
we
العدد
see
حاضر يمشي وأديك الشيفت.
Please close your microphones. Lowell, switch on your microphone.
Lowell, you need to switch on your mic.
Am I back?
Yeah, you're back.
Okay, good. In any case, what I was just saying, that a direct influence of population is on land use. A much greater land use for growing crops, for raising livestock, obviously for urban sprawl, for our own occupation, and a great decrease in woodlands and wildlands. So this is a direct influence of population. We also have, of course, the decrease in wildlife as a result of that, since they lose so much of their space to live. And so over the last couple of decades, we've lost a size of habitable land 8 times the size of the United Kingdom. This has led to what some people refer to as a catastrophic decline of wildlife species and extinction. So we have a direct influence of population growth, and of course, population then interacts with other variables, most obviously industrialization. So we have more people emitting more pollutants, especially carbon dioxide and methanes and so on, which is changing our atmosphere. Again, this has happened in the past, but it's unprecedented here in the amounts and the levels that we are doing this. There's still some natural emissions of this through volcanoes and wildfires and so on. But between our agricultural and urban settings and industrial settings, we are emitting great amounts of this, which is, again, as we all know, very much changing our world. And these two elements, which are so essential for us, carbon, all life is carbon-based life. So this is the source of life. Oxygen is what makes our eukaryote form of life possible. But then when you combine them and you release them in great amounts into the atmosphere, as we all know, all of a sudden those life-giving elements become life-threatening elements. And we've had this unprecedented increase in levels of CO2, carbon dioxide, in our atmosphere here within just recent decades. And certainly over the last century, for centuries, the levels of CO2 in the atmosphere were relatively stable up until the Industrial Revolution, where they've taken off and we have this unprecedented condition. It used to be thought we didn't want to go above 350 parts per million of carbon dioxide in the atmosphere. Well, we've blown past that, and it seems as though it just continues to rise. The same thing with methane. Methane is a mixed bag. It doesn't last as long in the atmosphere as carbon dioxide does, but it retains heat much more effectively than carbon dioxide. So the more that we release this on a steady basis, the more that we add to the problem of our global warming. And we are all familiar with how we have had an increase in our average temperatures, with the 10 warmest years on record, as long as we've been keeping these records. It's since 2005. Of course, it's not uniform. Nothing is the same everywhere. As we look ahead, where we see ourselves now is maybe 1% of the world is in a barely livable hot zone. It's just too hot to live there. But within just a half a century, that the portion of the world that could be almost unlivable due to global warming could go up to 19% or so. And we have this in certain areas of the world, which it seems as though it's going to be even worse than in other areas of the world. So it's global climate change is going to affect all of us, but it's going to affect some of us even more and make life difficult, miserable, maybe even impossible in certain zones, which is, of course, an enormous concern for all of us. And it's going to change a lot of different, it's going to have great impact. Right now, over the last few years, we have been living through the greatest refugee crisis since the end of the Second World War. But this current crisis that we have is going to be relatively minor in comparison to what we might be facing as a result of climate change. We're going to have internal migration, peoples moving within Africa, South Asia, Latin America, elsewhere because of this. So we'll have internal migration. We will in the United States as well. We are certainly not immune to all of this. So we already seem to be affected by this with greater drought conditions in the western half of our country because of sea rises. It could be that the millions of people who are living on our coast are going to find it too expensive or perhaps even too impossible to continue living. They will have to move somewhere else in the United States. This is going to cause enormous disruptions within our own country as we anticipate the future as a result of climate change. And obviously, those island nations, which are already just a few feet above sea level, could be completely submerged, and they will not have internal migration. They will be among those who are forced to have international, global migration, and so we can expect some hundreds of millions of people being displaced by climate change. Already, we are facing populism, these sort of ethno-nationalist reactions as a result of refugees moving around. We're facing that in the United States, and we're already experiencing this. There are people in Honduras who have suffered much more intense hurricanes, who are making their life in Honduras possible. They are being forced to move to other countries, including the United States. And we, this is part of the reason why we had Donald Trump as our president, because we've had this populist reaction against that. We're going to be facing some very serious political problems, which will be in line with all of this as a result of global climate change. But it seems as though this could be even worse in some areas because of that correlation between that map that I showed you of where it seems as though it's in South Asia or it's in sub-Saharan Africa, which might be among the parts of the world which are more affected by climate change even than other areas. And it's exactly in those areas of the world where we have the greatest population growth. It seems as though we have more population growth in Asia and Africa than in other parts of the world, and they will be greatly affected by climate change. So this just doubles the concern of that. The different couple of graphics of how this looks like it's going to be changing over the next remainder of this century. A total increase in peoples and a great increase in numbers of people in both Africa and in Asia here in coming decades. And then you look with a greater, finer tooth comb, and you just notice the greater increases in population in a number of African and Asian countries compared to some others. Here, we in the United States, along with other countries, are actually experiencing a population decline in terms of our own current populations reproductive rates. Having said that, we will be here in the United States among the 9 countries where half of the world's total population growth is going to take place as our century goes along. And of course, the way, so right now we have about 333 million people. By the end of the century, we're expected to have some 400 million people. And the way you put that together with our own reproductive decline is, of course, through immigration. So our total population, including new citizens from immigration, will be increased. But this will add to the tensions that we have in the United States. We are living in a very polarized political environment. At least this is what we talk about ourselves all the time. The red states and the blue states, and they seem to already be living in alternative universes, and that may continue in part because of immigration issues. but there's no uniformity in population growth. It's it's striking to those of us who have become so accustomed to think of China as the world's most populous country, now pressing 1.5 billion people. It's enormous, but the projections are that China's population will level off within a few years and then actually start to decline, in part because of their own the restrictions on reproduction, which they've changed here just about 5 years ago, and this will influence China in a number of ways because they have benefited from their population. They have all kinds of capabilities, but a very productive and abundant workforce is exactly part of what has made China such an increasing economic powerhouse. And so when they look at those figures, they're concerned not about population growth, but about population decline. And they need to be thinking, or they are thinking, about how they can limit or reverse that expected population decline. And it's not just an issue of how many people there are, but the demographics of population change. Specifically, we are expecting an aging population in a number of countries. Some countries have relatively youthful median ages, but in the United Kingdom, France, Germany, Russia, China, Japan, the United States, we have an increasingly aging population. More people are increasingly retiring for every working person there is. This will put great pressures on our Social Security system. It's going to be very expensive for workers to support guys who look like me in coming years. And that's going to create tensions between the productive workforce and the retired population. And how are countries going to be dealing with that? That's one of the things that China is looking at. Their aging workforce, their population decline means that in order to maintain the economic growth which they have enjoyed over the last 30, 40 years, this is a significant problem that China is going to have to deal with. Russia, too, is dealing with population decline, and they are not experiencing high rates of immigration, so their total population is perhaps going to continue to go down. This is a problem for Russia. So we think in terms of population growth as a problem. Many countries look at population declines. We have a whole list of countries where there is population decline, and governments there are trying to analyze exactly what are the reasons for this, what explains these declines, and how can they turn it around so they can have sufficient preservation of their population or growth. This is the more traditional human concern. How the state, how leaders, how societies should intervene in reproduction so that their own rates can sustain the group. This has been, for most of the human experience, a very common problem. It's at the global level, or in certain countries and certain regions, where population growth has given us unprecedented problems. So where does this leave us in total when we look at the big picture of global population growth in conjunction with industrialization? Are we just doomed? Is it time now to call out the hospice workers and just say that we're not going to be any more successful than the blue-green algae was in curtailing our chemical emissions, and we're going to cause not just the extinction of other species, but we're going to cause enormous problems, if not extinction, for ourselves. And of course, without this doomsday sort of approach, our concern in this webinar is to try to identify a few ways in which, rather than talking about creation or destruction, we can talk about preservation or sustainability. What can we do to make adjustments? Now, it's true that China has gone from its one-child policy to a two-child policy. That's part of what they want to do to try to encourage a reproduction. India, on the other hand, which is actually expected to overcome China as the world's most populous country, is considering a variety of policies which are going to be intending to restrict population growth. What can those countries which are experiencing what seems to be excessive population growth, able to do to curtail the harmful effects of that? My own university comes out of a Catholic tradition. That's a 2,000-year-old tradition. And again, thousands of years ago, the issue was, how are we going to reproduce enough to preserve ourselves? And you have in the Catholic tradition, which is very important in Latin America and Africa and elsewhere, this resistance to population control. So we have the claim is that effort has been a tragedy. Or here just the other day, the Pope was scolding couples who decided not to have children, who decided they wanted to have some pets instead of that. And so Pope Francis bemoaned the global decline in birth rates, at least in some areas of the globe. That's not certainly universal. That's a tradition which is rooted in the vast majority of our past, in which sufficient amounts of reproduction has been the problem. The trick has been, and one of the unprecedented needs that we face now, is how can we develop those values and those practices which do value life, but see that to preserve life, we need to have some changes in how we go about doing things. And so wouldn't it be better, I think, if I could say humbly, for this tradition that instructs my own university, to think about how a respect for and a reverence for life would now mean regulating, restricting population. But how do we go about doing that? Specific government policies which set limits on reproduction in many countries aren't going to work very well, or they're going to cause very unintended and undesirable effects, such as maybe what they did in China. It might be more indirect changes in the ways that we go about things, which can resolve this issue. One of the ways that we've talked about is one of the great changes over the last century or two in many countries has been the change in the role of women in society and in politics. As women have become more educated, as they have enjoyed more career opportunities, as they have enjoyed greater degrees of their own security, as microlending very often is targeted towards women's entrepreneurship. Women independently are choosing to have fewer children. This is not because governments have told them they can't do that, but they make their own rational calculations based on what their choices are. And this could be an indirect indirect way of slowing population growth and increasing perhaps human happiness. So these are the types of issues that we're going to be considering. My colleagues are going to be considering that in subsequent presentations about how we can understand this problem and how we can go about making some improvements so that in the future, when there are life forms that maybe are as distant from us as we are from the last universal common ancestor or from life forms from the Cambrian period, when future life forms look at the available evidence that they have, what will they see as our record, as our legacy? Will we be seen as having caused destruction? Will we be creative enough to find ways to preserve life? What will be the result of this picture that Sohan showed us? Will it have stimulated an environmental movement which leads to the preservation of life, or will the vulnerability of that blue earth in a very foreboding space overtake us, and that the extinction of life will finally leave us as a rather dark spot within an otherwise gleaming universe, and that is where we will be continuing our consideration here with future presentations. Thank you very much for your attention, and thank you again to everyone here at NoRCEL for having organized this very important conference. And I look forward to our the remainder of our day together. Thank you.